Okay, so for this video, we'll be doing the answers for your Chapter 11 Chemical Changes Revision Worksheet. Okay, so 1A chemical changes can be represented with a word equation. Study the word equation below and answer the questions that follow. So methane plus oxygen, it becomes carbon dioxide and water. So this arrow means that the reactants become the products. So on the left hand side will be the reactants. Okay, and on the right hand side of the arrow will be the product. So we see that there are actually new products that are formed. So when we have new products formed, it's usually a chemical reaction. So they want us to name the reactants. They will be methane and oxygen. So they react to become carbon dioxide and water. So the reaction above is an example of heating effect. What is the chemical reaction known as? So we actually have a few chemical reactions. You need to know what are they. Okay, these are the types of chemical reactions. Firstly, we have combustion. It is a chemical reaction in which a substance is heated in the presence of oxygen to form one or more new substances. That means there must be heating. Okay, it must be heated in the presence of oxygen. That means you must see oxygen being present to form one or more new substances. Okay, so this is combustion. Second one is thermal decomposition. Thermal is another word for heat. That means it's again involve heating. So what is thermal decomposition? It's a process in which a substance breaks down into two or more substances when heated. So this is a little bit different from combustion. Combustion is whereby the substance is heated in presence of oxygen. But now thermal decomposition is where a substance breaks down into two or more substances when heated. Now, the third one is oxidation. It is a chemical reaction where a substance gains oxygen. So example of oxidation will be rusting and respiration. Okay, and 1 and 3, combustion and oxidation, both involve oxygen, right? Gaining oxygen. So what is the difference? Later on I'll elaborate. I think I talked about this in class and I even posted the answer on Google Classroom. But later I'll go through it again. So just take note that oxidation, it is rusting and respiration. Number 4 is neutralization, right? It is very special. It is a chemical reaction that occurs when an acid is mixed with an alkali to produce salt and water. So these are the 4 chemical reactions that you need to memorize. Okay, what is the difference between combustion and thermal decomposition? Okay, thermal decomposition is actually breakdown of a compound. Okay, so there's only one reactant and 2 or more products. That means we start with 1, then we get 2 or more products. But combustion is combining oxygen with another reactant. So 2 reactants and 1 or more products. Okay, then what is the difference between combustion and oxidation? Combustion requires heat energy to be taken in, but oxidation may involve energy to be taken in or given out. All right. So or you can just memorize that oxidation, the process is the examples will be rusting and respiration. So for respiration, it is a process whereby our body breaks down food, okay, into energy. So energy is therefore given out. But combustion is therefore only requires heat energy to be taken in. There must be heat energy. So knowing all this, then we can go back to part 2. What is the chemical reaction known as? You see that there's oxygen being reacted with methane. So this answer must then be combustion. Okay. Now draw the model representation of methane and water in the boxes below. Do take note that the left hand side atoms is equals to number of right hand side atoms. Okay, so total number must be the same. So what we had, I believe this is oxygen, and this must be carbon dioxide, right? Because this is O and O, so 2O makes O2, right? So my O appears here, my O appears here. Okay, and what is the product? There must be water. So this must be my water. So water is H2O. That means I have 2 H and 1 O. So one of them must be like that. And H, I maybe use another one. Okay, I maybe color it all black. Okay. So this is my H, this is my H, and the center one is my O. So how then you ask yourself, how do I know what is methane? So they give you a clue here. The left hand side must be equals to the right hand side. So I have 1, 2, 3, 4. I have 4 O's here. I have 1, 2, 3. So I don't have the same number, correct? And over here I have 1 C. I have H over here, but it's not represented here. So I must have a C here, right? This is my methane. Okay. Then I have H. I have H. This one I color or black. Okay. Then will there be a balance? So there's no balance, right? But if you, so we have to think further. Now I have 4 O's here. 4 O's, So over here I only have 2 O. I have 1 O. Okay, so that means I must have another water molecule. That means I'm going to have one more here. Another H, O, and another H. Okay, so now I have 1, 2, 3, 4. 4 O's on the left hand side. I have 1, 2, 3, 4. 4 O's on the right hand side. So now the O's are balanced. That means I have 1, 2, 3, 4. 4 H's. 4 H. That means here I must have 4 H. And then I have 1 C. Okay, so this will be balanced. Alright, but this is tough because you need to know what is methane. Okay, but you should always try to make sure the number of atoms on the left hand side must be equals to the number of right hand side. Now, chemical changes occur when substances interact with oxygen or certain forms of energy. From the list below, choose one or more conditions needed for that following changes to occur. Decomposition of calcium carbonate. So this is our thermal decomposition. So thermal decomposition is a process in which a substance breaks down into 2 or more substances when heated. So it will definitely need heat. Okay. Now, electroplating a coin with copper, it will need electricity. Okay, so this is one of the application of chemical reactions. Now, preparation of magnesium oxide from magnesium. So oxide, you must know that it comes from oxygen, right? So magnesium is actually the reactant, and I want to prepare my magnesium oxide. So my magnesium oxide will be the product. Okay, that means it's magnesium. I need to have oxygen. Then it will form by magnesium oxide. Okay, so this must then be combustion. So combustion, you need heat, you need oxygen. Okay, now formation of an X-ray. So formation of an image on an X-ray film. So this one actually need your light. Okay. Then breakdown of water into its element. Breakdown of water into its element. Okay. So this is electricity. Okay. So this is a process called electrolysis. Okay. So all this can actually be found in your notes. So it is important to sort of memorize a few examples. Now we go to question 2. Name the processes with the following word equation. So we have sulfur plus oxygen to form a new product. So plus oxygen, that means this must be combustion, right? Because it involves heating with oxygen. Now carbon dioxide plus water becomes glucose and oxygen. So this is your photosynthesis. Okay. Next, we have calcium carbonate. It becomes two products. So this is your thermal decomposition. By now, some of you will be saying, hey, so it's so unfair. How do I know that whether heat is involved? Okay. Most of the time, heat will be involved. Okay, unless you recognize some other process. In fact, photosynthesis, it involves light energy. Okay. Now, hydrochloric acid is your acid plus sodium hydroxide. So this is actually your alkaline. So this must be neutralization. Later I'll do some revision on acid and alkaline. So sodium chloride is actually your salt. So a product will be salt and water. So glucose plus oxygen becomes carbon dioxide and water. This is actually respiration. Right? Now, question 3, the labels on a bottle of nitric acid and a bottle of sodium hydroxide have fallen off. So basically, it is an acid and an alkaline. Okay? So give two simple tests. It can either be chemical or physical that you can carry out in a science lab to differentiate the contents of these bottles. Then, for each test, you must briefly describe what you will do and state what you will observe. Okay, so this is the test 1 suggested. Place red and blue litmus paper into each solution. So the hydrochloric acid, because being an acid, the pH is actually less than 7, sorry. It will turn blue litmus paper red and red litmus paper will remain red. Sodium hydroxide is an alkaline, so it is having a pH greater than 7. So greater than 7, yeah. So it will turn red litmus paper blue, blue litmus paper remain blue. So this is actually a physical test. It is not a chemical reaction or a chemical test. Okay. Test number 2, you can actually place a small amount of calcium carbonate into 2 test tubes. So vigorous bubbling will be observed when acid is added to calcium carbonate as carbon dioxide is produced. But for the sodium hydroxide, there will be no bubbles produced. Okay, so for this, I will go to the reactions of acids and alkaline. Okay, so what are acids? Acids example we have in the lab is a hydrochloric acid. You need to know all this. It's actually in our notes. Hydrochloric acid, so we also call it HCl. We have nitric acid. It's HNO3. And we have sulfuric acid, H2SO4. So what is common among the acids? Do you notice that there's actually a H, H, and H? Which means when they are dissolved in water, they will form H plus ions. Okay? So of course they will form Cl minus ion, but I don't care about that because that's not common between them. So for all of them, they will actually have the H plus ion. Now let's look at the alkaline. So examples of alkaline, we have sodium hydroxide. Okay, so for sodium hydroxide, it is NaOH. We also have potassium hydroxide, which means it is safe to assume that anything that ends with hydroxide, it is an alkaline. So we have KOH. What is common among them again? They have the OH in them. So OH minus will be formed when they are dissolved in water. Later, I'll also go through some characteristics of acids and alkaline. Okay, but for now, you need to know that acids will have H plus ions, which is hydrogen ion. Okay, and alkaline will give hydroxide ions. which is OH minus. So what happens if I add acid and alkaline? I add acid to alkaline. One of the product will be salt. So it depends on what kind of acid it is and what kind of alkaline it is. But one of the sure product will be water. Because we have H plus, which definitely comes from acid. We have OH minus, which definitely comes from the alkaline. So when they are added together, they form our H2O. So this is known as neutralization. Because as you know, the pH of water is equals to 7. Yes? Now acid has pH less than 7. Alkaline has pH greater than 7. By combining these two together, I should get water which has a pH of 7. That's why one of the reactions that you need to know is neutralization. It involves adding acid to alkaline. Okay, so this is one of the reactions for acids. We have two more reactions. The other one is acid plus metal. It will give salt plus hydrogen gas. So how do we test for hydrogen gas? Okay, once the gas is produced, we put a lighted splint. Let's say we do it in a test tube. Okay, we add some metal, then the acid, then there'll be some hydrogen gas. If we add in a lighted splint, so what will happen to this lighted splint? It will go off. It will extinguish with a pop sound. It will extinguish with a pop sound. So these are things that you need to memorize. Okay. So if now I tell you I add something, I add a metal to a liquid, and then I see that there's a gas produced, there is bubbling, there's effervescence, there's a reaction, and I test the gas using a lighted splint, it goes off or it extinguishes with a pop sound, then I know that it is hydrogen gas. Then I know that the liquid that I added was acid. So this is the second reaction for acid. The first one is acid plus alkaline. It forms a salt and water, which is known as neutralization. Second one is acid plus metal. Okay, it will form hydrogen gas. But do take note, not all metals can react with acid. Not all metals react with acid. Okay, so some are special. I think you can find them in the notes. I think one of them is gold. Okay, that's why it's very precious, right? I think silver also do not react with acid. Okay, so most metals do react with acid to produce hydrogen gas, but not all metals. Okay. Okay, next, the third reaction is acid plus carbonate. Okay, acid plus carbonate. Copper, silver, and gold do not react with acid. So next one is acid plus carbonate. You need to memorize. Okay, as you can see, carbonate. So carbonate, that means it has carbon. It will also have oxygen. Okay, I know it's not very fair for you all now because you all never really learn this, but you have to sort of memorize. So if acid plus carbonate, you will form salt, carbon dioxide gas, and water. Alright, so the key feature that's being produced here is your carbon dioxide. How do we test for carbon dioxide? We bubble this gas into lime water. Okay, bubble the gas into lime water, and it will actually form white precipitate. What is precipitate? Precipitate, it means some kind of this lime water is actually liquid, so it's clear at first, clear liquid. But when carbon dioxide is bubbled in, there will be a white precipitate. That means there will be something cloudy that's being formed. Okay, please refer to your notes for this. Okay, so these are the three reactions of acids you need to memorize. Okay, then now we drifted a bit, so let's come back to here. Okay, so that's why when we want to test whether is it acid or alkaline, we can use carbonate. Okay, we can use carbonate. So basically, carbonate will result, if it's an acid, there will be carbon dioxide being produced. Okay, there will be carbon dioxide produced, and therefore there will be when we bubble the gas into lime water, there will be a white precipitate. Okay. Okay, then we go to question 4. Question 4, I think you didn't really learn it. Okay, so they say explain why limestone removes sulfur dioxide from the waste gas. So this is a power station, right? As you know, it creates a lot of pollutants. Okay, but we actually need the energy lah. So basically on combustion, the sulfur is oxidized to sulfur dioxide, which is this. Dioxide means 2 of this oxide. Then we have nitrogen dioxide and we have carbon dioxide. So all of these are actually waste gas. So these waste gas are actually also known as your greenhouse gases. Okay. So explain why the limestone removes sulfur dioxide from the waste gas. So I'll just copy the answer and show you all. Okay, so the calcium carbonate in limestone. It's like, then how do you know calcium carbonate is present in limestone? Yeah, so maybe not really in our G2 syllabus. So it reacts with sulfur dioxide to form calcium sulfate. So again, something that you will know, and carbon dioxide. So basically, carbonate has a tendency to produce carbon dioxide. Okay, so this actually removes the harmful sulfur dioxide from the gas, but it produces carbon dioxide. So which one is a bigger evil? The sulfur dioxide is a bigger evil. Okay, carbon dioxide is still okay, right? Then describe an harmful effect of releasing sulfur dioxide into the environment. So if let's say we do not remove this sulfur dioxide, it is being given out to the surrounding. It may cause acid rain that corrodes limestone building and structure. Okay, yeah, so this is all for this chapter. So for this worksheet is very short, but actually there are a lot of things that you need to memorize in the notes. All right, so please read through your notes on chemical reactions.